Hi, everyone. Welcome to this Low Trophic Life webinar hosted by the Aquavita project. It's great to see that so many of you have joined us already. We're going to start in just a little bit. I'm going to do a quick introduction first. First of all, myself, I'm Emil. My name is Emil Bremnes. I'm a communications advisor here at Nofima, the Norwegian Institute of Food, Fisheries and Aquaculture Research. So again, welcome to this webinar. And since we've got quite a diverse audience here today, not that many people who have joined us before, so a lot of you are actually new to these webinar series. Just want to say that every single month, the last Thursday of every single month, we're hosting these webinar series, and it's a platform for young researchers and professionals who are either involved in Aquavita or linked to it in some way. They get the chance to present their results from different research areas and then talk about them to an audience. And it's great that so many are here already. And I imagine that a lot more people are going to join us as we go along. So this is a Teams live event. I just want to explain that. You guys won't be able to see anyone but me and Kristina. But on the box to the right, you have this Q&A box. So you can ask questions there, just write them in there. And towards the end of this webinar, we're going to go through them. So feel free to write questions whenever you'd like. If you have a question right now, you can put it up there, and we'll take it at the end of the webinar. So usually we have Phil, who's the project coordinator. He usually does this introduction about Aquavita. He couldn't make it today, so I'm going to give a quick intro to the project itself. So Aquavita is a Horizon 2020 project. So we've got, it's a 4-year project. So we're almost halfway through it. We've got 35 partners in total, which includes universities, research institutes, larger corporations, and even SMEs. And in addition to the 35 partners, we've got about 165 stakeholders around the world that are also participating in the project. So it's a huge project, massive project. We cover 4 continents all around the Atlantic and 16 countries. And the project itself is focusing on supplying food from the ocean in a sustainable way through increasing the production of low trophic species all across the Atlantic. So that is the goal of the project. So we're covering 5 different value chains, 11 case studies plus 2 cross-cutting case studies, and in addition to that, 9 work packages. And we're looking at everything from the profitability of low trophic species to sustainability and how we measure that sustainability, and trying to find solutions for low trophic species production in the Atlantic. Right, so today we're going to be focusing on mussels. And so the case study 9 in the project is what covers mussels. And it looks at offshore production of blue mussels. And there are 3 main challenges that have been identified for the mussel production in exposed areas in the northern Atlantic. So the first challenge is the development of robust production technologies that are adapted to these local conditions in exposed areas. The second is ensuring a stable supply of mussel larvae or seed. And the third one, which is relevant for today, is ensuring high quality mussels without biofouling. And to solve all these challenges, Aquavita is going to test different new and modified systems for mussels production to better cope with these conditions in these exposed areas. And the focus here is on submerged tube and net systems and a platform made out of concrete and steel, developing easy to operate hatchery protocol to ensure seed. And finally, most important for today's presentation, is developing a protocol and field-based non-toxic anti-fouling method. And this is what Kristina is going to present today. So Kristina, I'm going to introduce her right now and then invite her onto the stage in a second. Kristina Svedberg, she works as a marine biologist for the aquaculture company Bohus Havsbruk in Sweden. And she did her master thesis on the decreasing mussel population in 2019. She did that for IVL. And after that, she continued working with research regarding mussel conservation and how to use byproducts from aquaculture as a resource. So Kristina, welcome.
Thank you.
Right. So before we start your presentation, I don't know about everyone listening, but at least for myself, so fouling was a new concept to me. Could you just take us briefly through what fouling is and how it relates to mussels?
Yeah, so fouling is basically in the marine habitat. There are a lot of species that settle onto hard substrates. So for instance, if you go swimming or snorkeling by some cliffs on the coastline, then you're going to see barnacles sitting on that cliff, and you're going to see algae, and you're going to see mussels and oysters and sea squirts. And all of these animals and plants, they need places to hold on to because they usually filter the seawater. So they like to be in one place and they don't move. And usually they settle on cliffs, but they can also settle on your boat. They can settle on docks. And the mussel shell, since it's hard, is basically like a rock to these creatures. So, for instance, a sea squirt can see a mussel and be like, oh, this is nice. I'm going to hang out here. And then it will settle on. So you can have sea squirts on mussels. You can have algae on mussels. You can have bryozoans and oysters and like all these creatures that like to sit on something, and they don't move for their entire life stage. So once they find their place, then they're just going to sit there.
So how can this fouling become a problem for mussels production?
Well, the problem is basically that usually if it's soft fouling, like for instance a sea squirt, then you can remove it during the harvest. So it can usually be removed in the process of harvesting the mussels. But if you have something harder, like for instance an oyster or a calcifying worm that I'm going to talk about today, then they have these hard shells and it's very hard to remove them. So that can be an issue, not because it's affecting the mussels in most cases, but mainly because it does not look appetizing and appealing to the consumers.
Right, that's a really good point, and I'm really looking forward to hearing your presentation. So if you want, you can get it ready right now, and we'll put it up on the screen, and Kristina is going to run through her presentation in about 15 minutes. So after that, obviously, we're going to do questions. Any questions you might have, as I mentioned, put them on the box to the right, and we'll take them at the end of the presentation. So right, I see we've got the presentation ready to go. So if you put that in full screen mode, Kristina, I'll give you the word.
Thank you, Emil, so much for the introduction. Hello, everyone. I'm very happy to be here. And I think we should just dive into today's topic, which is fouling on blue mussels. Can we find a sustainable solution? Now, since all of you don't work with mussels, I'm just going to go through some basic facts in the beginning. So mussels are filter feeders. As I said before with the fouling, they sit on one place and they filter the seawater. And when they filter the seawater, they could take up a lot of nitrogen and phosphorus from the seawater. And this means that when you harvest the mussels, these nutrients are taken out of the marine system. So this is a good thing to do for eutrophicated coastal areas. They spawn in May and June, when the seawater is about 8 to 12 degrees. And the larval settlement is in late June, or as we in Swedish like to call it, midsummer. Now for mussels in aquaculture, I'm going to go through it a bit briefly, since I work for a Swedish aquaculture company. So this is from a Swedish perspective. But we're situated on the west coast of Sweden, as you can see on the map here. And this is a very good place to grow mussels because you have the high salinity water inflow from the North Sea and the Atlantic that you don't have on the rest of the coast of Sweden. On our farms, we use a smart farm system where we have PVC pipes, and from the pipes we hang nets and ropes. So you put the net in when there is larvae in the water in the summer, and then the larvae latch onto the nets, and then you leave the nets for a year and a half, until they reach consumption size. So when they are about 5 to 10 centimeters. Now, when you harvest, if you find mussels that are smaller than this, then you relocate them to ropes using a lower density so that they can grow out a bit more. And we also used wild spat. So we don't grow any mussels to get larvae. So we just put out the nets into the ocean. Now, since we grow the mussels in the ocean, we can get a lot of fouling. And one of the fouling creatures that we get is the calcifying worm, Spirobrancus ticketer. Now, we don't know a lot about this worm. We don't know when it settles. We don't know the growth rate. And most importantly, how do we get rid of it? What we do know is that it doesn't like light, so it usually settles further down, maybe 3 to 6 meters, not in the surface. And we also know that it's gregarious. And what gregarious means is basically that once you have the worms on the farm, the likelihood of getting more worms increases. So they like to sit with each other. Now I'm going to show you a picture of how it can look when it's at its worst. So to the left, you have a picture of a net, and you can see all the tubes from the worms. And if you want a game, you can try to find the mussels on the nets. I think I've found 4 mussels on that picture. And to the right, you have a rope, also with these tubes. So there are several issues with the tubes. Either they can settle on the nets before the mussels, and then the mussels don't have any place to be, or they can settle on the mussel, and that's when it becomes an issue. So if you have mussels with a lot of worms, then we can't sell them to the public because it doesn't look appetizing or appealing, even though the quality of the mussel meat is still good. So the settlement of these worms are different from year to year, but this can lead to a 10 to 80% yield loss. So you can basically lose a whole farm of mussels just because you have these worms. Now, as I said before, the mussel meat is still totally fine, so I like to compare them to crooked carrots. If you go to a grocery store and you buy carrots, they are usually straight. And this is because the crooked carrots are discarded beforehand. And it's the same case with the mussels. And also, if you were presented with a crooked carrot and a straight carrot, then you would probably choose the straight carrot, even without knowing it by yourself. And even if you would have a mussel with a lot of worms on it and a mussel without worms, then you would probably want the one without worms for your dinner. As Emil and I spoke about before, a lot of other people's species settle. You have sea squirts and you have sea urchins and barnacles, but these can be removed during the process because they're not as hard. They don't have this hard shell. So it's not an issue in the production. But now I'm going to talk about the solution to this problem, which is a heat treatment that we have been working on. So for the heat treatment, what we do is basically that we give the mussels a nice long 45-second bath in different temperatures and try to see if we can make the mussels survive and the worms die. So we have tested a span of different temperatures from 30 to 55 degrees. And as I said before, we dip them in for 45 seconds, as you can see on the picture here. After bathing them, we put them in regular seawater for 2 days, and then we check the mussel survival and the worm mortality. So for the worm mortality, what we do is we crush the bottom end of the tube where the worm lives, and then it's going to be really sad because we are destroying its house. So it's going to want to crawl out, and then we can see if it's alive or not. For the mussels, if the mussels are open, what you do is that you knock them on a hard surface. And if they close, then you know that they are alive. So we do this after 2 days, and we also do it after 2 weeks. And our goal is a 90% mussel survival and a 90% worm mortality. So we basically want as many mussels to survive as possible, and as many worms to die as possible. So these are some of our results. I'm going to go through these graphs with you. So to the left, you have the worm mortality, and to the right, you have the mussel survival. The yellow line is testing that we did in June last year, and the green is from October last year. And you also see the gridded area in the top corner of the graph. And this is where we want to be. This is our goal. So for what we could see was that for 50 and 55 degrees, we achieved a goal of over 90% worm mortality. But unfortunately, if you take a look at the mussel graph, you see that a lot of mussels died. The survival was very, very low for 50 and 55 degrees, especially in June. Almost all of them died. So what we decided to do was to look at this area right before this starts to happen, because we were wondering what is happening right before this. So we did a fine-tuning experiment where we tested a smaller range of temperatures from 40 to 46 degrees. And I'm going to go through this graph with you. So here we have a box plot. So to the left, you have the control with worm mortality, and then you have 2 boxes for each temperature. So for instance, for 40 degrees, you have the orange box and the gray box. And for 43 degrees, you have the yellow box and the blue box. And for instance, for 40 degrees, the orange box is 45 seconds bath, and the gray one is 90 seconds, because we decided to test different exposure times. And what we found was that with a longer exposure time, you get a higher mortality of the worms. However, there is a lot of variation in this graph, as you can see. So therefore, we will do more testing in spring of 2021. We also looked at some seasonal variation. So here we have one graph which shows the worm mortality after 48 hours, and one graph that shows worm mortality after 2 weeks. And what we found was that it differs after 2 days. So in October, a lot of the worms died after 2 days, and in November, almost none of the worms died. But after 2 weeks, they're about the same. So to conclude this, there is a seasonal variation. So it's important to avoid the spawning season of the mussels, because this is when the mussel is the weakest. Exposure time affects mortality. This means that if you don't want to invest a lot of money in heating up the water more, then you can just use a lower temperature and use a longer exposure time to achieve the same result. And it's also important to treat as soon as possible when you find these worms. So the smaller the worms, the better. And this was everything that I had. Thank you very much.
Thanks a lot, Kristina. Really, really fascinating stuff, especially for someone like me who's I've really got no clue about mussels or decalcifying worms or fouling, as you heard in the beginning. So it was really, really fascinating for me as well to learn, and you explained it in a really easy to understand way, I think. Right, so no questions have come in so far, but if you if you have a question that you're burning to ask, then put it in the questions box. But in the meantime, I want to ask you, Kristina, how common is this problem with decalcifying worms? Like maybe not just in Sweden, but in Europe as well, the rest of Europe.
Well, like I said before, there hasn't been a lot of studies done on these worms. Our method is based on an Australian experiment from 2012. So we know that they have the same issue there, not with the same species, but it's related to that species. And you also have some studies done in Scotland. So you have this worm all over the world, and you have the problem with the fouling on the mussel. But as I said also, it varies from year to year. So some years you can have it like almost at the surface and then all the way down, and it's on all of the mussels. And some years you almost don't find any, or maybe you find ones at the very bottom of your ropes.
Right. So, but you mentioned that it could be sometimes between 10 to 80% of the yield. So, I mean, 80%, that would be quite a detrimental number, wouldn't it, for a mussels producer? You've been waiting 18 months to harvest these mussels, and you're coming close to that, and then suddenly, we lost it.
Yeah, it can be a huge loss. And also in Sweden, there are a lot of small companies that work with this. So if you only have a small farms and you get this, it can be really devastating. And as well, if you have 80%, you might lose 100%, because if you as a person should go through all the mussels and try to select the ones that don't have fouling, you're likely to miss some actually good mussels. So when it's 80%, it can actually be 100%. So what you have to do as a mussel farmer is basically not to put all your eggs in the same basket. So if you have several farms and one of the farms has a lot of fouling, then maybe you have one farm that almost doesn't have any fouling at all. So that is what you have to do, but that is why we are looking at a solution. And I should also say that this experiment is ongoing. We're not done with the data. We're like right in the middle. I did some analyzing earlier today, actually. So that is important to note, because this is a lab trial, but later in the project, we're going to try to do some field testing, because it's nice if you just have a net of mussels and stick it down in a lab, but you need to be able to do this out in the field as well. So we will be using big, almost like tubs that you can set on a barge out on the farm, and then you can just drag the ropes, the 6 meter long ropes, through this. But before we do that, we need to find the exact right temperature and the exact right exposure time.
Of course, you need to make it as efficient and cost effective as possible, obviously, yeah. But yeah, I get that. Huh. Very, very interesting. So right, we've got a few questions that have come in already. So Matilda is asking here if there are any EU regulations that get in the way of selling mussels with worms, or crooked carrots for that sake.
Well, I don't think that there are some EU regulations, not that I know of, but it's mainly that different countries have different, how to put it, they want mussels of different qualities. So for instance, if you're in France or in the Netherlands, then they might be very specific that they only want mussels that are 5 or 6 centimeters without fouling. Now, for Swedes, we don't eat a lot of mussels. So in Sweden, you might be able to sell a 10 centimeter long mussel that actually has a few worms on it, and it will be fine. So I think it's just that, different countries have different tastes in how the mussels should look like. But that is one of the issues. So you could either attack this problem by saying that the worms are not harmful to the mussel, and you can just boil the mussel and eat it, and it won't taste any different. Or you can say that, okay, if people want to have this perfect, nice, black and shiny mussel, then we need to get rid of the worms.
Fair point. Good point. Right. So there's a question here when it comes to the market acceptance point that you just made is from Mercedes at Setmar. She's wondering, is there any estimation, or can you comment on how this this removing and this anti-fouling measures could increase the value or market acceptance of mussels?
Well, I would say that if you can't sell the mussels, they become waste. And at least in Sweden, you have to pay to remove your waste. So you will actually have to pay to get rid of the mussels. So like if it would cost a bit, it would still be that instead of waste, it would be a resource. And we have also checked if you can strengthen the numbers on the natural mussel beds by putting these mussels with fouling out in order to help the natural mussel population, because all around the world there are indications that the natural mussel population is decreasing. So there are a lot of ways you can use this.
That's really interesting. I like the fact that you try to also help the natural processes through this low trophic species production. That's very good. Right. So there's so many questions coming in. I think it has to do with this being a very interesting topic, and at least you, Kristina, being a good presenter. So here's a question from Joshua, who's wondering, instead of trying to kill or remove the worms, have you looked into avoiding them settling in the first place? So he's saying here, researching when there is a peak settlement and moving the mussels to avoid it, temperature, season, and with regard to depth difference as well. And he thanks you for the presentation as well.
Okay, thank you for the question. We are actually looking at the settling dynamics of this worm as well in Aquavitae as a different study. So what we do is that we put down ropes into the seawaters, either with cupels or with mussel shells, just to see when we have peak settlement. Because then you could remove the mussels, or you could see that, okay, we need to treat them this week because this is when they will settle. So we did it now for the fall. So what we know is that at least in Sweden, where we tested, they started coming in August and they stopped settling in November. And now I actually put out ropes 2 days ago. So now we're going to see if we have a spring settlement as well. So there are testing being done in this area.
That's great. It's good to cover the whole field in order to find the best possible solutions. Excellent. Right, so there's a question here from Nicolina, who's from Greenland, and she's asking, could it be the water, the warmer temperature and lower salinity that gives I'm going to mispronounce this, but Spirobrancus the advantages? So, and then she's wondering how it is in northern Norway, because she lives in Greenland and they do not utilize mussels or produce mussels at this point.
Yeah. Okay, let's see. It was a long question.
So the first part was about if it was due to the warmer temperatures and lower salinity that gives them the advantage.
Yeah, like I said before, there are a lot of knowledge gaps, but the reports that have been made about this worm is that there are some indication that it likes warmer waters and that it likes a lower salinity. There's also this one report from 2002 that was done in Scotland where they said that they can't build the tubes when the temperature is lower than 7 degrees in the seawater. So this is very interesting, but like I said before, we don't have a lot of data on these worms. And I think it's an issue with, like, if you have a new interesting invasive species, then a lot of people are going to want to look at it, or if it's a species that we use a lot. But if it's a species that you just find and you don't find particularly interesting, you're not going to start the research until it's a problem.
That's a good point. Now, the next question here is, I'll take this one first, actually. It's someone who says they're very sorry if they missed this, but I don't think this topic has been covered. So they're asking, do the worms actually compete with the mussels for food in any way? And are there any, do you know of any predators to the worms in their natural environment?
Well, like I said before, there are a lot of knowledge gaps. They are filter feeders, just as the mussels. But we don't know how much this affects the mussels. So my guess is that maybe if you have one worm, it wouldn't be a problem. But if you have a lot of worms covering, then it might be an issue for the mussels to get food. But the mussels that we have harvested that has fouling on them, they have still grown to consumption size. So at least where we are, it doesn't seem to be a problem. But I think if you would be more offshore and there would be less food, then it might be a bigger problem.
Yeah, good point. Very good point. And we're doing some more research into more the offshore production. I mean, your case study or your work, Kristina, is focusing more on coastal waters. Am I right?
Yeah, exactly. Almost all of the mussel farms in Sweden are actually situated in fjords. So we're closer to the shore also because we have a lot of islands and we had a lot of archipelago in Sweden, and we don't have a lot of space that is offshore because we're enclosed by Denmark and Norway. So we can't do a lot of studies on that. But the case study leader for case study 9, Pernille Nielsen, who works for DTU in Denmark, she knows a lot more about this offshore aquaculture farming. So if you have any questions about offshore aquaculture, I think that Pernille is the one to reach out to.
Good. Yeah, that's very true. And when it comes to scalability, so here's a question that has to do with scalability. What's your opinion on the feasibility of this type of treatment? So considering that at a large scale production, mussels would have to be removed from the water and then replaced for later harvest.
I'm not sure I understand the question. Can you take it again?
So the way I understood it is that, you know, if you have quite a large scale production and you have to heat all these mussels to a certain level in order to remove these worms and then replace them back in the farm.
Yeah.
How scalable is that technology or that method, to put it that way?
Well, we actually tried to calculate so that if we have these big tubs that we pull the ropes through out on the farms, how long does it take to do a whole farm? And at least in our case with our farms, it would take 8 hours to do that. So then you would probably not get any harvesting done that day. But if you look at it on a longer perspective, if you have 5 farms, for instance, in an area, and you take 1 week to do the treatment on every farm, then if you look a year from then you won't have as many worms on your mussels, and then you will be able to sell more. So I would say that just that week, it may be labor intensive and you may lose some money because you can't sell the mussels that week, but you will be able to sell a lot more mussels a year from now. So it's like a long-term investment, I would say.
That's a very good point and well explained as well. Right, so we have no more questions in the question box for now, but I want to I think we might wrap up soon, but I want to finish with one question, and it hasn't got that much to do with these new solutions, but more in general with mussels production in Sweden at the moment and how it's been affected by COVID, or if it has at all. Could you say a little bit something about that? What's it like for you guys producing mussels at the moment?
Yeah, it's a bit difficult at the moment because we're a really small company. And we just started selling mussels actually to the public just 3 months before COVID hit. And then it was fine during the summer because we didn't have a lot of cases of COVID in Sweden during the summer. So people were out eating on restaurants and the restaurants wanted our mussels. So everything was fine. We had a lot of work. And then this fall, when the second wave came, and the restaurants shut down and people didn't go out, and then just everything dropped. I think we lost 70% of the people that bought our mussels in maybe 2 weeks. So yeah, everyone just shut down really quickly. But the good thing about mussels is that they won't go bad. If you don't sell a banana, it's gonna rot after a few weeks or a few months. But with the mussels, since they are alive before we harvest them, we can just keep them in the ocean. So right now, we don't have any harvesting out on the farms. We just, everything is just shut down. And then sometimes we go out and check that everything is still there. But hopefully when everyone gets vaccinated, people can start going to restaurants again, and then we can start to harvest again. So we just sit and wait patiently and hope for this pandemic to be over.
Thanks for your honest answer, and also for sharing all these details. But I don't know anything about this, but do the mussels get huge, or do they have sort of a max size of 10 centimeters?
Well, I have not seen mussels that are bigger than 10 centimeters, and it's also like in a year and a half, you might get mussels that are 5-6 centimeters. So for them to be 10, you usually have to wait for 2 or 3 years. And this pandemic has only been going on for about a year. So right now it's not an issue, but also like we can't invest in new nets for like new settlement at the moment. So if this pandemic would be ongoing for maybe 3 years, then it would start to be a really big problem.
Yeah, I can imagine. Just losing 70% of your customers in just 2 weeks could be damaging enough to any company, I imagine. Yeah. Right. So I just want to finish this webinar by saying thanks a lot, Kristina, for your presentation and for sharing your knowledge and your experiences from both from the production side of you, but also, of course, the science in there as well. So thanks so much for sharing. Do you want to say a few last words to our listeners?
Well, I think you just, I'm very happy that you listened today to my presentation, and I just want to encourage you to listen to the other presentations as well, because as Emil said before, this is a really big network, and we have so many different species that we work with. We have mussels, we have oysters, we have abalone. So yeah, just continue to look at this webinar series and see the diverse science that is going on in aquavitae.
Excellent. Thanks a lot, Kristina. So it's goodbye to everyone. Thanks for listening. Oh, my post-it got stuck. Thanks for listening, and see you next time, next Thursday, last Thursday of March. See you then at 2 p.m. Bye for now. Bye.